All right, we're moving right on into multiplying polynomials. So I want you to think about the math that you already know how to do really well, and multiplying is one of those. So a lot of you have been, you've been multiplying since 3rd, 4th grade, and you can take something this simple and multiply it out, and it's not a problem. So polynomials means that now we're just adding a variable into those, okay? But all of your processes that you use to do that are exactly the same. So, for example, first we're going to do a multiply a monomial times a polynomial. So I want you to think about if you had 3 times 47. And really, what are you doing when you do that? You're doing 3 times the 40 and 3 times the 7. So you have 120 plus 21, and that gives you 141. Even if you set that up vertically, right? There's our 21, and I scoot one over. And there's our 12, giving us 120, exactly what I've got there, and you have 141, okay? Exactly that. We're going to use exactly the same methods to multiply polynomials. So, I need to remember your exponent rules. When you multiply a same base, you just add the exponents, okay? So we're going to deal with our coefficients first. So I'm going to show you a couple of ways to do this. So one is just do straight distributive property. I think all of you are very capable of doing that. Sometimes you might miss a sign, so you need to be really careful about that. So do your coefficients first. Negative 3 times negative 4 is negative 12. X squared times x cubed, just add up the exponents to get x to the 5th. Negative 3 times negative 2 is positive 6. X squared times x squared is x to the 4th. Negative 3, if there's no number in front, we know that's a 1. So negative 3 times 1 is negative 3. And I have x squared times x, which gives me x cubed. And then negative 3 times negative 10 is positive 30. And I have x squared times 1, essentially, which gives me that. Okay. I'm going to show you a couple of other ways that you can multiply that. One of them being very similar to this. So let me actually move this over a little bit so I've got some room. And you're going to see that it's exactly the same steps that we did with straight numbers. So this, I'm assuming, is not a process that intimidates you at this point. You've been doing this forever. And I just want you to apply this process to a polynomial equation, okay, or expression. So, like you would do here, I'm going to stack the larger polynomial on top. So I have 4x cubed minus 2x squared plus x minus 10. Okay, and then on the bottom I'm going to put negative 3x squared. And you essentially are just going to multiply that negative 3x squared times each of those terms, just like you multiplied the 3 to each of these terms. Okay, so we get 30x squared positive, negative 3x cubed, negative 3 and negative 2 times negative 2 is 6, x squared and x squared is x to the 4th, and negative 3 times 4 is negative 12, x squared times x third is x to the 5th. So either way you do that, you're going to end up with identical answers. Okay, in this unit I'm going to show you 4 different ways to multiply polynomials, and it's up to you to decide which way really makes sense to you and you can really master that skill really well. This is by far one of the skills that you will take out of this class that's going to follow you into your next 2 math classes at least, but probably every math class after this. So it's a skill that I really want you to have down really well. Okay, so one thing we can do is called using a table. I call this box method, and actually a student taught this to me. This is the Hannah Rayburn method, because she taught this to me when she came to my math class when she was in 8th grade. And it's essentially making a grid, and it kind of works off of those multiplication charts that you used to do when you were in elementary school that would have 1 through 12 across the top and 1 through 12 down the bottom, and you had to fill in the multiplication table. Exactly the same thing. So you're going to take one of your polynomials and put it across the top, one term in each box, and then the other one down the side. Now, it does not matter. I'm going to do it the other way too to show you. It doesn't matter which term you put on which side of the box. So in this one I'm going to put 4x plus 2 and 2x minus 1. Either one is fine. But it doesn't matter as long as your signs are correct. You need to keep your signs with the right term, and you cannot mix these two. So you can't put 4x minus 1 down one side and 2x plus 2 on the other side. You must have the terms matching here. So now you're just going to go box to box right there. So you're going to drag down. So I'm going to do 2 times 4 is 8. X times x is x squared. And you're just going to do that for every box. 4x times negative 1 gives me negative 4x. 2x times positive 2 gives me 4x. And 2 times negative 1 is negative 2. You'll see that even though I flip the boxes around, I get exactly the same answer if I do that over here. Okay, so once I have that, now I'm just going to pull this information out of here. So I have 8x squared, and I'm going to go ahead and list them in descending order in the first place, which makes my job in a minute a lot easier. Okay, now in this case, and you need to simplify it all the way. So if you have, you're always going to have a middle term here. So what's usually going to happen is you're going to have terms on the diagonal that need to be combined. In this case, they just happen to cancel each other out. Negative 4x plus 4x cancels out, and your answer is just 8x squared minus 2. So really, and you can keep that middle term in there if you want. 4x minus 4x is just 0x's minus 2. Either way is acceptable. You will rarely see a question on an exam or on a worksheet or anything like that written with that 0x in there. You'll always see it like this, but you need to know that that x term is still there. There's just 0 of them. Okay? Okay, you can apply box to any size polynomial. A binomial times a trinomial, a fifth polynomial times a 10th polynomial. It just gives you a way to organize it so that you have everything accounted for and you make sure you're multiplying every term. So in this case, I've got a binomial times a trinomial. So obviously if I've got a 2-term binomial, that's going to go on my 2-box side. And my trinomial, the 3 terms are going to go across the top because that's where I've got 3 columns to work with. Okay, and now you're just going to multiply. Coefficients first. If there's no number in front of the x, we know it's 1. For now, until you get comfortable, I want you to write those 1s in there. They don't hurt you to have them there, and they definitely help. So 3 times 1 is 3. X squared times x, just count up your x's, and you've got 3 of them. Negative 2 times 1 is negative 2. X to the first times x to the first is x squared. 4 times 1 is 4, and I've just got x to the first. Now repeat that for the second. So you've got negative 15 x squared. Negative 5 times negative 2 is positive 10, x to the first, and negative 5 times 4 is negative 20. What you'll notice is this very first top left corner and bottom right corner. Those will not combine 99% of the time with anything. Those are going to be your standalone terms. Okay? What will combine are the diagonals that you have here. So now you're just adding those up. You've already done your multiplication. You're just adding those up. So I have negative 15 minus 2, which gives me negative 17x squared, and positive 10 and positive 4 is positive 14 x to the first. There's your answer there. Okay. So I'm going to show you 2 more methods. One I'm going to call horizontal, and the other term I usually use for this is double distributive. And then I'm going to show you a vertical method, which is exactly actually what you did way back here with the multiplying 47 times 3. That's what I based vertical method off of. So sometimes you'll hear FOIL. If you already know how to do FOIL, that's great. I will actually show you that method in here also with the horizontal, because it is a horizontal method of multiplying. So I will show you that first. I will tell you that I don't really care for FOIL. I think more mistakes get made with FOIL than need be, and the other methods are a little bit more linear and organized and tend to eliminate those mistakes. So FOIL stands for first, inner, first, outer, inner, and last, meaning the terms that you're dealing with. So let's take this. Remember that if we have something's squared, it means it's being multiplied by itself. In this case, 2 times. So first means that you are going to multiply first term to the first term, the outer terms together, the inner terms together, and then the last terms together. So we would have 2x times 2x. See, already this looks not organized to me, but it's a personal preference, and I don't care which way you multiply polynomials as long as you can do it really well consistently. That's my goal. So 2x times 2x is 4x squared. And negative 5 times 2x would be negative 10x. Oh, I did my inners before my outers. Sorry, let me go back. I don't use this method now. You can see why. 2x minus 5 is negative 10x. Negative 5 times 2x is negative 10x again. And negative 5 times negative 5 is positive 25. Again, we need to simplify those terms together. So we would get 4x squared minus 20x. Oh, sorry about that. Screen blanked off and I didn't realize it. Plus 20x plus 25. Okay. When you multiply a binomial times another binomial, you will end up with a trinomial. Look what happened back here when we multiplied a binomial times a trinomial. So a 2 by a 3, we ended up with a 4-term polynomial. Think about what happened when you multiplied just your regular numbers. You had a 2-digit number and a 1-digit number. You ended up with a 3-digit number. Will that happen all the time? No, you can find plenty of examples where that won't happen, but a lot of times it will. Okay, so let's do double distributive. So what double distributive says is let's take one of those terms and just break it up. So in this case we have 2x and negative 5. And then we're going to multiply each of those terms by the other one. Okay, so I've got my 2x minus 5 here, there, and then this one I broke up and put it there. Now you're just doing distributive property. So 2x times 2x would be 4x squared, and 2x times negative 5 is negative 10x. Now you scooch down here. Well, if negative 5 times 2x is negative 10x, so I'm going to line it up with the other negative 10x, and then negative 5 times negative 5 is positive 25. Now you've got them lined up, and you can just add them right down the columns. Okay, this is actually not a bad method. It's very linear. I definitely prefer this to FOIL. Again, if you've been taught FOIL previously and you understand it really well, please just stick with it. That's completely fine. If you want to give another one of these methods a try just to see if you like it any better, that would be a great idea too. Okay, so I'm going to show you vertical now. And vertical uses this same idea that you had when you were multiplying regular numbers when you were a kid, right? What did we do first? We took that first term, multiplied it by everything in the top. So we had 4, 8, 12. Then we moved down one, made a space by putting a 0 there or some kind of space marker. I always just put a 0. And then multiplying the 2 by everything on top. So you have 2, 4, and 6, and then just adding down the columns. Right? So vertical method with polynomials is exactly like this. The only difference is now you've got letters in there, but we know how to handle them. We're really good at our exponent rules, so we can do this. So list your larger, just like you had the larger number above, you're going to do that with your polynomials. And I would start it over here because it's going to kind of work its way to the left. So I have x cubed plus 2x squared minus 2x plus 4. If you want to add the ones in there, just to keep yourself kind of in check, that's fine. And then we'll have 2x minus 4. If you don't need the extra ones in there, perfectly acceptable, perfectly okay. As long as you are multiplying those correctly. Okay, so now you're just going to start with a negative 4, and you're going to multiply all of those top terms. So it works exactly like this. If you get confused, you get lost, think, what would I do over here? If I just took all of the variables out, how would I handle it? You're going to do it the same way. So negative 4 times positive 4 is negative 16. Negative 4 times negative 2x would be positive 8x to the first. Negative 4 times 2x squared would be negative 8x squared. And negative 4 times 1x cubed would be negative 4x cubed. So far, so good. Now we're going to move down a row, put a space there, and just put a 0. And now we're going to multiply 2x to the first times that whole row. So 2x to the first times 4 is 8x to the first. 2x to the first times negative 2x to the first will give you 2 times negative 2 is negative 4. X times x is x squared. And then 2 times 1 is 2. X to the first, oh, I missed one, didn't I? 2x to the first times 2x squared would be positive 4x to the third. And then 2x to the first times x to the third would be 2x to the fourth. Now, what I really like about this kind of goes back to our adding and subtracting vertically, is that everything is lined up. And you can just bring your terms down and then just add up. So negative 16 plus nothing is negative 16. 8 and 8 is 16. Negative 8 plus negative 4 is negative 12. Negative 4 plus 4 is just 0. So if you wanted to write it without that term there, that would be okay. And then we just have a 2. Okay? So you're going to have an opportunity in class to practice all of these methods and choose the one that really speaks to you and makes a lot of sense to you. I'd like you to try a couple now. And just try a couple different versions and see which one you think. Going through the notes, you probably had one that you thought, oh, I think that one I like. So try 1 or 2 different methods and then come back and check your work. So I'm going through and doing this problem actually 4 different ways to kind of help you see the differences. And it's going to be up to you. Let me scooch this one down a little bit. Vertical. It's going to be up to you to decide which way you prefer. One person's preference is certainly not going to be another's. But essentially, no matter which way you choose, you will always come up with the same answer. So you should have gotten 4x squared minus 16. And you can put this on pause and look at the different ways that I did that and see if it compares to yours. The last one, I'm just going to do box and vertical because those tend to be the 2 most common that people choose. So this one would be 2 by 3 box. So if I get that total, I get 7g cubed. 4 minus 56 is negative 52g squared. This is a 1g, so negative 31g minus 8. Vertical method, I would have 7g squared plus 4g plus 1, and g minus 8, so that would give me negative 8. Negative 32g, negative 56g squared. G, 4g squared, and 7g cubed. So probably a lot of it depends on whether you're kind of more of a left-brained or right-brained thinker, whether you're more linear or whether you're more kind of artsy. And although typically it's interesting, my more artsy kids tend to really like box method and vertical method because it's very organized. So there you go. We'll do lots of practice in class. See you in 7-3.